Ever.
Done. On. On.
Hello? Hello? Good morning.
Good morning.
Morning, ladies and
Good
gentlemen.
morning.
Hello. Thank you for coming today to this session,
Good
which
morning.
I am a pleasure, ladies and gentlemen. Thank you for coming today to this session,
Someone
which I am a pleasure,
the YouTube session.
Thank you for coming today to this session.
There is a loop of our audio. The YouTube session. There is a loop of our audio. You have YouTube open. Okay, so to everyone, please close the YouTube window because we are hearing our audio. So mute YouTube, please. Okay?
Okay, thank you. So let's open this session. I remind everyone that you have 10 minutes for your presentation and 5 minutes for discussion or questions. I'm going to interrupt you about 1 minute before the talk finish, and I'm going to stop you once 10 minutes is up, okay? Let's open immediately with the first paper. It is Human Behavior Prediction for Risk Analysis. And the presenter is Adam Snickers. Is it correct?
Yes, Sakaresh.
Okay. Okay, Adam, you can start. Thank you.
Thank you. Can you hear me properly?
Your presentation, everybody can see it?
Okay, so I hope you can hear me. Good morning, everyone. My name is Adam Sakaresh. I'm about to present our paper titled Human Behavior Prediction for Risk Analysis. This work was conducted at NTNU in Norway. To give you some basic background, this work is a step in the development of the conflicting incentives risk analysis method, which was developed in the domain of information security and privacy. It places humans at the center of the risk analysis, despite the fact that information security is a highly technical field. This work assumes that humans are fundamentally responsible for security or insecurity. And in this method, risk is the result of misaligned incentives, which means that there are two types of stakeholders, the risk owners and strategy owners. The strategy owners' incentive is represented on the x-axis. The risk owners' incentives are represented on the y-axis, and two types of misalignments between the incentives is possible. One is in the fourth quadrant, which refers to threat risks. These are very similar to the traditional notion of risk. The other type is in the second quadrant. These are opportunity risks, which is the lack of some desirable outcome happening, and these risks are faced by the risk owner due to the actions of the strategy owner. This method replaces the incident or probability estimations with the strengths of human motivation. It does not rely on historical data, and it assumes that we require proper methods for human behavior prediction. Overall, the aim is to simplify the risk analysis procedure. The main motivation for the work is that traditional behavior prediction approaches in general are not very effective. Predicting human behavior is difficult, and in the literature, various personality or personal features have been proposed to make predictions, such as introversion, greed, lack of empathy, and so on. But the accuracy is generally low. For example, the theory of planned behavior, which is one of the most established method for behavior prediction in psychology. Most studies only focus on intentions as opposed to actual behavior. The accuracy is quite low, which is measured by the square metric. Behavior, the accuracy is quite low, which is measured by the okay, I can hear my cat now. Which is measured by the yeah. So the R squared can be 40% for intentions and drops to 10% usually for when actual behavior is measured. And an observation is that the influence of situational attributes on the decision maker are rarely included in predictive models. So therefore, the objective of this paper was to propose and evaluate a proof of concept for psychological behavior prediction, which fundamentally utilizes features of situations to improve the predictive capabilities of Zero. We have developed 2 research questions to guide the activities. The first one is related to what extent can predictive accuracy increase using an approach which takes into account differences in the perception of situational influences among decision makers, comparing it to a traditional approach which only uses personal features. And the second research question is about to what extent is the proposed method feasible when the situation perceptions need to be estimated by risk analysis without having access to the subjects. Because in the method, it is assumed that people are not cooperative, they are not motivated to reveal their true motivations. In the method section, I can describe quickly, use the anonymous questionnaire implemented in Lime surveys, which was hosted on NTNU servers. And we collected 2 types of data. One was behavioral data, which operationalized the 2 risk types by moral and altruistic dilemmas. And we collected personal features by a validated psychometric instrument called PVQ-21. A total of 59 responses were collected during the data collection, and the mean age was 34 years. So the main sections of the questionnaire are centered on 9 dilemmas, which were developed in a previous work. They were designed to capture threat and opportunity risks. And the order of data collection, we first collected the behavioral data, the first part, and each dilemma consisted of a story or a context, setting the stage, setting up a difficult moral problem. And each of them had 2 options, 2 mutually exclusive options, which the respondents had to evaluate on 5 dimensions. The rating scales were provided as sliding scales. So each dilemma, both options of each dilemma were evaluated on these 5 dimensions. Then in the next section, second section of the questionnaire, we collected the personal features, the basic human values structure, which is a theory describing how decision-making takes place, and the decisions are driven by the trade-off between the various dimensions of the personal features. And the final section collected explicit choices, so people had to make a decision whether they would execute some action or not. The first research question interested in exploring how well the proposed method functions, and this provides an overview of the descriptive statistics. We calculated the utility score for each choice by summing the ratings given by respondents. In this graph, we can see how many, the percentage of yes answers with the red graphs, and the number of internally consistent choices, which gives an indication of data validity, meaning whether respondents were following instructors, and subject rationality, meaning that people were acting rationally, making choices according to the stated preferences. Based on this data, we can say that relatively high validity and subjects acted rationally. We compared the traditional and the proposed prediction method by conducting 2 sets of 9 binary logistic regressions, using in the first set of analysis the basic human values profile, referring to the traditional approach, and the ratings, subjective perceptions, as independent variables in the second set. In both sets, the identical outcomes, the choices were the dependent variables. And in 7 out of 9 cases, the proposed method outperformed the traditional approach, which is a quite positive improvement. The second research question was interested in about the feasibility, and for this we calculated inter-rater reliabilities or intra-class correlations to estimate the extent of objectivity in situation evaluations. It can be seen that objectivity ranges from quite low to...
You have just 1 minute, please.
Which means that people perceive situations quite subjectively. This raises questions. So we think that predictability is the essence of security. And if we make human behavior at the center of risk analysis, we need better models for predicting the human behavior. So this study focused on proposing and evaluating a method for improved behavior predictions. And it was shown that this proof of concept is promising. It consistently outperforms the traditional approach, but further work is needed to improve its utility in settings where unobtrusive assessment is the only option for the risk analysis. In the future, it would be desirable to increase the accuracy of these perceptions, and this can be potentially achieved by training analysts in situation assessments or by making these assessments automated in some way to increase reliability. So thank you for your attention, and please ask.
Thank you, Adam. Are there any questions or comments to this presentation? No? I have just one question, Adam. Did you select or know the level of the education level of interviews?
Yes, we collected that one as well. It was, I didn't have place on the slides, but the paper describes the education level. I can probably find it somewhere. Most people had a bachelor's degree, 46%. Then secondary education, 36%. And the rest had master's degree or lower secondary education.
Okay, thank you so much. Thank you.
Yep.
We can go on to the second presentation.
Okay, thank you.
Yes. The second presentation is a deep learning approach to forecast SARS-CoV-2 on the Peruvian coast. Who is going to present this paper?
Hello, me.
Okay.
I am Antonio. I will be the presenter.
Okay.
Okay, I will begin the presentation now.
And sorry, what's your name, please?
Antonio, I am one of the authors.
Okay, okay.
The
Antonio
last
Aguilar
one.
Gutierrez.
Antonio.
Exactly, yeah.
Okay,
Yeah,
thank
exactly.
you.
Okay, now let me please in this. Well, good day, everyone. My name is Antonio. I am part of the CAP AI Tech research group in Peru. I will be the presenter of the paper SARS-CoV-2 forecasting on the Peruvian coast, a deep learning approach. This study was focused on developing a deep learning model to estimate the daily COVID cases. Now, this will be the main agenda. We will talk about the introduction, previous work, the methodology, the proposed model, the training strategy, results, the evaluation metrics, and the conclusions. So let me first talk about a little about Peru here. Peru is mainly composed by three geographic areas. We can see here we have the Amazon rainforests, the highlands, and the coast. The main reason of this study to focus on the coast is that these regions, which are composed by 9 regions, which are Lima, Callao, Ica, Piura, Lambayeque, La Libertad, Tumbes, Tacna, and Moquegua, present a very high density population area. This means that SARS-CoV cases here are more predominant than in these two other areas. Therefore, the infections in this area have a broad impact in the highlands and the Amazon rainforests. Therefore, it is important to develop a system which will be able to forecast and estimate those cases. Now, this work was made using previous works. First of all, we know that among the many models, we have parametric models and non-parametric models. For example, at the early stage of the pandemic, the SEER model and its variants were useful to estimate the COVID behavior, but these models tend to be too strict in the way in which they assume the data distribution. Now, in deep learning, we can use different models, for example, feed-forward neural networks, more complex architectures like LSTM or RNN models, and also complex models too, like autoencoders or convolutional neural networks. Our goal here was to use a model which can be estimate cases using the past information, but at the same time not use in a direct way and recurring network. Now, our model was a variation of CNN. I will describe it now. But before that, let me talk here about what is the main methodology that we use. We begin with the raw data, in this case from the Ministry of Health here in Peru, which is called MINSA. And as you can see here, this is the basic machine learning pipeline. We go to the steps processing, and here in training, we actually developed the model to estimate the daily SARS-CoV-2 cases, and we present a training strategy. Also, we have as an objective forecasting 15 days ahead. Then we can use the forecasting, but in the forecasting, we were very interested in a model which can also forecast future data points when no actual training or testing data was present. And finally, we made an evaluation. We have here, this is the main pipeline. Now, you can see here our proposal model. This is a temporal convolutional neural network, or a TCN. And this model is basically a variation of a convolutional network, which three main components. First, each convolutional block, we apply two kinds of convolution, causal convolutions and dilated convolutions. The main idea here is that the causal convolutions keep the natural correlation of the data, which is something that we want since we are dealing with a time series problem. And dilated convolution allow us to see a broader view, and this allow us that more deep layers can see more broader patterns. And these networks implement also skip residual connections. So with these components, you can see here the main architecture. We have a convolutional block followed by a batch normalization layer, a ReLU activation, and a dropout to avoid overfitting, as well as the residual connections. Now, we decide to implement an end-to-end approach. Since we were estimating the daily cases, we need a model which can assess that variability. In this case, we decided on outputs to include a lower, middle, and upper prediction intervals. We achieve this using this loss function. I know this is a quantity loss, which enforce the model that each layer will learn a specific representation. And using that, we perform two stages in training. First, we create a Bayesian optimization using a validation dataset in which we tune the hyperparameters and the architecture with the objective of minimizing this loss. That way, we were able to achieve this architecture here. And using that model, we finally train on all the training data, okay? And we also perform the classical evaluations in regression programs with this metric, PIC, which stands to prediction interval coverage probability, which measures how well these distributions are captured. Okay, now here are the results. Now, what we can note here are three main things. First, we have the 9 regions that I mentioned before. And for each one of them, you can see the variability in the predictions, here marked by this blue area. Also, you can see the mean prediction, in this case, in the orange line. And also, you can see that, in fact, we were able to forecast beyond the available data. Moreover, with this information, we were able to group the regions according to the risks in which they will have more or less cases in the 15 forecasting window. In this case, you can see that from April 2021 onwards, which was at the moment of the study. Finally, these results correlated with the metrics. Here, the train and test data are measured in the validation and training sets. And remember that we use a Bayesian search here and on the validation data. And what is now see here is that the test results actually show a great improvement in contrast with the validation set. And also, we were able to capture that distribution of the data, which you can see here in the train and in the test data sets as well. So, what can we conclude here? Well, it is possible to approximate the behavior of subcore cases using deep learning approach. We were able to apply an end-to-end solution. Bias optimization helped us a lot to speed up our experiments. And finally, a TCN model can achieve robust results in presence of very noisy data. So thank you so much. If you have any question, I all ears here.
Thank you, Antonio, for staying time.
Yeah, I will add.
Thank you so much. Are there any questions, comments? Antonio? No comments, no question. It's okay. Thank you so much again. Bye-bye. See you. We can go on with the third presentation, analysis of ontology quality dimensions, criteria and metrics. I think that the presenter is Shayama. Is it correct?
Yes, hello.
Hello?
Yes, hello. Can you hear me?
Yes.
Yeah.
Can you please share your screen, Shayama?
Yes, sure. And I'm sorry, I cannot find my presentation. So can it? Yeah.
You cannot find the presentation?
Yes, I think I already opened my presentation, so I'm unable to share it.
What?
Can't
You're
you
not
hear me?
able to share the screen? Or you're having problems in, I don't know, the computer? Do you know how to share the screen, Shayama?
Yes, I can find the share screen button on the screen, but
Okay.
when I click on it, I cannot find my presentation on the window.
You can find your presentation.
Okay.
Can you see it right now?
Okay?
Can we see? We don't have your presentations.
Okay. No, can you see it right now?
No,
No?
we can see.
I'm sorry. Okay, so now I can find it.
Okay.
Now it's okay.
I'm really sorry about that.
Don't worry. It's okay.
Okay, now it's fine. I think now all can see my presentation.
Yes?
Okay. Good morning, everyone. Myself, Shama Wilson from University of Colombo School of Computing, Sri Lanka. Today, I am delighted to be here to present my research work, analysis of ontology quality dimension, criteria, and metrics. First of all, let me introduce you what is ontology and why. Ontology is a formal, explicit specification of a shared conceptualization.
Shayama, sorry, but the slides are not gone on.
I'm on the slide number 2.
We are still seeing the number 1. You
Oh
have
my God.
to close the full presentation, maybe, on your screen. No, not everything, just on PowerPoint.
I'm really sorry.
Okay. Try to go to the next one.
Okay, so I was talking about what is ontology. So ontology is a formal explicit specification of a shared conceptualization. In a simple way, we can consider ontology as a conceptual model of a domain of interest that define a common vocabulary for researchers who need to share information in a domain. Uh, and Actually, why ontology useful when compared to other data bases, data model, meta models, and dictionaries? Actually, ontology has distinct capabilities such as to share a common understanding of the structure of information among people, law software agent, to enable reuse of domain knowledge. Also, it can act as a knowledge base that can make available explicit knowledge as well as implicit knowledge by inferring the explicitly defined knowledge. Then, why ontology is important for information system? And let me take
Shayama,
yes.
we can see the second slide, and the slides are not going on.
Just don't put the full screen, okay? And go
Okay.
on like that. Okay.
Okay.
Okay, I'm sorry. So
Okay.
then let me explain why ontology is important for information system. So uh, I'll take an example in the agriculture domain. Decision making is the most important part of the farm management, of which farmer needs to take the right decision at the right time by gathering information from various sources such as from domain expert, agriculture department, perhaps from books, website, and from colleagues. Thus, the farmer should have good analytical skills to analyze the gathered information and make the right decision. To this end, having an intelligent decision support system is vital, and in such a system, ontology is the heart where all required knowledge is stored. However, such a system will not work unless a good quality ontology is used. Uh, Thus, we explore the existing work on ontology quality, and we realize that there are no universally agreed criteria and metric for ontology quality assessment. There are no definitions for ontology quality criteria from an ontological point of view. Thus, the existing criteria and metric defined in the literature so far messy and vague. Finally, there are no a set of criteria for evaluating different levels of the ontology. Thus, uh, through this work, we analyze the existing work on ontology criteria and metric with the end in mind to streamline the finding and provide an overview of the ontology criteria levels and approach. For that, some data quality theories were adapted from software engineering. As a result, we identify 5 quality dimensions. I'll further explain in the next slide. Under that, the existing quality criteria were classified. Additionally, the metric was provided to show the association among the ontological criteria, ontology levels, and approaches, as well as we identified that the similar analysis as we have performed has not been so far. So, in order to perform our analysis, we selected 13 quality articles in the considered domain. For that, we perform a search on digital databases, libraries, and the search engine. using the search terms as mentioned in the slide. And also we use a set of inclusion criteria to ignore the irrelevant and poor quality papers while searching. And through our survey, we identified 15 ontology quality characteristics, and that were classified under the identified distinct dimensions such as syntactic, structural, semantic, pragmatic, and social. Also, the existing ontology approaches and levels discussed in the previous works are listed here. You can see it. And let me quickly brief the levels. The syntactic level considers the properties related to the formal language that is used to model the ontology, and the structural level considers the properties like hierarchical relationships. The semantic level considers the properties of non-hierarchical relationship and the semantic element of the ontology. The lexical level concerns the named vocabulary of the ontology, and context level concerns the application aspects of the ontology. And we listed all the characteristics under each dimension. Now you can see this is the way of how we have classified the identified characteristic. The characteristic related to the formal language were defined under the syntactic dimension, and the characteristic describe the structural property were grouped under the structural dimension, such as complexity, modularity, internal consistency. Also, corresponding matrices were mapped with the characteristics. So, for example, the size, depth, and breadth are the matrices related with complexity, and cohesion and coupling are the related matrix with the modularity. Similarly, other characteristics also were classified by studying the corresponding ontology features of each level. As I mentioned, and in the previous slides, I highlighted two characteristic: consistency and completeness, because that two characteristic can be further decomposed into the sub-characteristic. The completeness characteristic can be divided into two characteristic: coverage and functional completeness. The coverage describe the completeness from the real world perspectives, and that means whether the ontology covers the real world knowledge with respect to this specified context. And the functional completeness describe the completeness from the user perspective. That means whether the user provides whether the ontology provides sufficient knowledge for users. That's therefore we classified it under the pragmatic dimension. Similarly, for consistency, also we divide into two characteristics: internal consistency and external consistency. Internal consistency evaluate the quality that is inherent to the ontology. External consistency concern whether the ontology consistent with the real world knowledge. Finally, we provide an overview which presents the existing ontology quality evaluation approach and what are the possible levels can be assessed and what are the related metrics with it. Say for example, application-based method can use to assess the context level with the characteristics, functional completeness, accuracy, ease of use, so on. And the expert-based method can be used to assess the quality of all levels. Especially, it is the one that can use to assess the structural and syntactic level. And the data-driven approach can be used to assess the semantic and lexical level, because in the data-driven approach, assessment is done using the corpus that was used to build the ontology, and the golden standard based approach can be adapted to evaluate the semantic and lexical levels, perhaps context and structural level as well. So there are a few more things to do. They are finding formalized definition for criteria and metrics, and modeling a quality assessment approach for ontologies, and also finding empirical evidence with regards to the proposed theories. Thank you very much for listening to my presentation. Sorry for any disturbance.
Thank you so much, Shayama, for your presentation and for staying time. Are there any questions, any curiosity or comments for Shayama? Okay, thank you, Shayama.
Thank you very much.
Bye-bye, see you.
Bye-bye. See you.
The last presentation, semantic improvement of question answering system with multi-layer SATM. Who is going to present this paper?
Hi, Francesca.
Hi.
Hi.
How are
So
you?
I have one request that actually me and one of my colleague Gina Tara, who is the fourth author, both of are going to present. So I will present half and she will present next half. So
Okay.
shall I start?
Okay, yes, the floor
So
is
I will share my portion. Then when I will finish, she will start her portion.
okay.
Is it okay? Yeah. Thank you, Francesca. Yeah. Okay. Just a second.
Sorry, what's your name?
My name is Hanif.
Anif.
Hi.
Thank you, Anif.
Just where it is, yeah, here. So can you see?
Yes.
Can you see the presentation?
Yes.
Okay, that's good. Okay, so thank you very much, all of you. So it is my immense pleasure to give me an opportunity to present my research work in front of all of you. So I am Hanif Bhuiya and my colleague Gina Tara are going to present our research work. Our research topic is semantic improvement of question answering system with multi-layer LSTM. This is a one kind of empirical analysis of a question answering system, because if I give you one example, you know all of you that nowadays in bank or several organization actually proposing a chatbot instead of human. So why? So this is a one kind of cost-effective task and system. So suppose a few days ago, I just asked in one chatbot in a bank that I want to see my PIN number, which one I forgot, but they usually took me in the option of PIN changes. So which one I actually not asking? I was asking I want to see my PIN number. So this is a one kind of inconsistency what we follow. So we in this research work we try to cover up this kind of problem through LSTM network. Okay. So this is the outline of our presentation: introduction, motivation, objective, the proposed model. I will present until the phase 2, then the rest of the things will present my colleague. So if I go in the introduction, what is question answering system? The question answering system is a popular human machine interesting approach to satisfy the user by retrieving correct answer or information of a specific question. But nowadays the massive storage of data and the heterogeneity of data and also the people's way of asking question is really heterogeneous. So all of these things actually makes this processing system little bit complex day by day. So considering this issue, several intelligent question answering system is developed already to answer the query of the user or customer based on the structured or unstructured data. But most of the works based on until now the AI-based and knowledge-based work. But among these works, to the best of our knowledge, that most of them they did not actually consider the semantic mapping of the whole sentence. They usually considered the keyword similarity. Based on that, most of the system works. So considering this issue, actually we're trying to propose a system which can work on the whole meaning of the sentence, actually what user are asking or what is the questions we want to understand through the network. Regarding that, we proposed one LSTM network model to improve semantic understanding and representation of the question answer token. So what is our contribution of this work? We actually proposed a LSTM recurrent neural network. We incorporate ReLU activation function and softmax attention mechanism. In particular, ReLU activation function actually helps in the network that which information have to go forward or which have to drop. The softmax attention mechanism helps to obtain the semantic similarity. And later we also incorporate max pooling function and Adam optimizer. Both of them actually helps reduce the data loss and also improve the accuracy of the network. So this is our proposed model. This model actually works in 3 phases. First phase is actually the input phase and embedding. Second one, this is the multi-layer LSTM network. We use 4 layer, and finally the question mapping and answering. So in the first layer, we usually give the answer, question and answer. We use the WikiQA dataset, which is the very common popular dataset for this question answering research. Then we feed this information into the network. Then we apply the activation function, softmax and other mechanism to gain the output. So if I go one by one, the phase 1, this is the input processing and embedding phase. This phase is also called the input phase. In this phase, we take question and answer as set as input. We mention as a set Q and A, and also we fix the length of the question and answer to overcome the overfitting of the network. And this is the second phase, the network architecture of this system. Only the less LSTM architecture. So as we know that LSTM means refers the long short-term memory network. It has actually 3 steps: input gate, forget gate, and output gate. Input gate determine which input information of the network has to remember or save for the current cell to add the neuron state. Forget gate used to remove some unnecessary information which no need to process to the next stage, and the output gate which give us the output. So until now, actually I presented. The next part will present by my colleague Jinat Ara. Jinat, are you here?
Yes.
Can you share? I just stopped.
Yes, I can share it.
Sorry for the bothering.
Is it okay?
Yes, we can see the presentation, but the first slide gone.
Okay. Thank you for giving me the chance to present the rest of the part of my paper. I'm Jinat Ara, and I'm a graduate student from Jahangirnagar University, Bangladesh, and I'm working with my colleague. And as my co-author already said, my proposed model is semantic improvement of question answering system, and he have present all the parts probably from here.
Sorry, did you share, Jinat?
Yes.
All of you can see the presentation?
Yes, we can.
Okay. Yeah, Jinat, Korean.
Okay, from here, our phase 3, my co-author already said, in phase 2, we have implemented our proposed model, long short-term memory LSTM network, and it's how it works. He already told everyone. From now, I present the rest of the part of the paper. Okay, in phase 2, we have already implemented our LSTM, multi-layer LSTM architecture. But in phase 3, this is the major part of our work, because in this work, we are trying to improve our semantic improvement. And in phase 3, we use several functions for improving our semantic similarity. That's why we call this phase as a QA feature mapping and sequencing phase. So here, after initializing the multi-layer LSTM architecture, we use some activation function to the neural state, and as an activation function, here we use ReLU function. Why you use ReLU function? There are all another activation function as well as, but we use ReLU function because it is more convenient to understand how it goes, how it works from one layer to another layer, and so on. That's why we use ReLU function. And ReLU function, of course, help us to identify which information should be passed to the next stage and which information drop at the same stage. And ReLU function also helps for semantic improvement as well as, that's why we use ReLU function. And after deciding the information like QA tokens, then we use the attention mechanism to the next stage. Here we use attention mechanism, and of course there are several attention mechanism as well as, but here we use softmax function because softmax function is quite popular, and most of the neural network have used softmax function. That's why we also prefer the softmax function. And softmax function actually work here to mapping the question answering tokens. As we try to improve the mapping process of question answering tokens to improve the full performance of semantic understanding of a particular sentence. Therefore, we use softmax function, and of course, softmax function also help us to improve, to reduce the loss of data. And then finally, we here use some optimization technique, and one is max pooling and another one is Adam optimizer. Max pooling actually help us to identify the fixed weight of input and output words, and based on this identification work, it passes to the next stage, and Adam optimizer actually determine or calculate the whole weight process and provide the final output result, and also Adam optimizer help us to improve our accuracy result. Okay. After initializing our model, we implement our model through Wikipedia question answering dataset. We also say WikiQA dataset. WikiQA dataset launched in 2010 by University of Pittsburgh for academic research, and it has 1,165 pairs of question and answer. And of course, we have some incorrect and missing answers and questions, of course. And it has different types of questions like different domain information, personal information, historical information. We have yes/no question answering, support fact, and lots of other things as well. Okay. Then we do some preprocessing because, as we previously said, we have some null values and other tags also. That's why we have to do some preprocessing for improving our accuracy. So first, we remove all the HTML and punctuation tags from the question answer text, and then split the full sentence into question and answer to feed into our proposed model. And then we use Keras tokenizer for perform the tokenizing, and then we do some post padding and post truncation for converting equal length of question and answer sentence. And post padding and post truncation are most common actually in most of the data processing system. That's why we also use this, and these techniques are also effective for improving your accuracy. Okay. Then training data. So here we train our data set, and we consider 80% of our data.
Gina, your time is finished, so I have to ask you to wrap up your presentation, please.
Okay, can you give me 1 minute more?
Yes, finish.
Okay. Here we use 80% of data for training and rest of the 20% for testing. And then we implement LSTM network. Here is our LSTM network. Here we use dropout layer, and we have several hidden numbers. And we here use dropout layer for avoiding the overfitting problem, and we set 0.2 dropouts. And here is our performance analysis result. This figure shows our accuracy into different number of epochs. As we say, in 30 epochs, we have 78% accuracy for training and 76% for testing. But when we extend the epoch number from 30 to 100, we have 83% training accuracy and 81% testing accuracy. So from this one, we can say that if we can extend the number of epoch, of course, we have some good accuracy. It's a huge chance to good accuracy. And we train our model from some 200 epoch, but after 100 epoch, the result will remain same. That's why we can consider the 100 epochs result. And here we compare our whole system, our proposed model results with existing three proposed model like multi-layer LSTM, mesh LSTM architecture and LSTM CNN architecture. And after comparing all the results, here our proposed models result, both training and testing results are quite good rather than comparative to other proposed models. Okay, so here we used LSTM architecture through recurrent neural network for improving the semantic understanding, and we perform an experiment through one specific QA dataset. There are also some dataset like squared, CMAPL, SQ, SCI QA dataset, and in future we have a plan to do implement these kinds of dataset. These are open source dataset, and of course in future we will evaluate our model considering more existing approaches. Thank you.
Thank you, Jeanette. Are there any questions?
But I want to thank you, Francesca, to give us the opportunity to present.
You're welcome. You're welcome, Hanif.
Sorry for time extension.
No questions? No questions? Okay. We can close, we can close this session. Thank you, everybody. Let's see in exact. Bye-bye to everybody.
Bye-bye. Thank you.
Bye. Bye.
Bye.
Bye.
Bye. Thank you so much.
Morning.
Live streaming is on.
Okay.
Okay. The title of this paper is Learning of Binary Relations for Finite Sets Through Automated Computational Implementation Using Raspberry Pi with Mathematica. The authors are Robert Ipanaquechero, Ricardo Vélez Moro León, Felicita Velázquez Fernández, and Daniel Flores Córdoba. The introduction is technology influence you through the massive use of electronic equipment and applications. Faced with the situation, the idea of reinforcing binary relationships with the use of Mathematica science software was born. Research that has been done show quite positive results of the use of different software in education. As a complement, a Raspberry Pi computer is used due to its low cost and for its advantage that there is a free version of exclusive Mathematica for this type of computer. The new package, DiscreteSets.m, is executed by accessing Mathematica on Raspberry Pi. To code the command, we use Mathematica's ability to manipulate and convert strings. The DiscreteSets.m package was developed for the graphical of-list representation of the automation of binary relation for finite sets. To code the command, we use Mathematica's ability to manipulate and convert strings. For accessing Mathematica in Raspberry Pi, then, we load in the package DiscreteSets.m. The binary relation command admits a maximum of 4 arguments and deletes 2, namely binary relation. It represents the element of the binary relation in the form of a list. The binary relation, it represents the element of the binary relation in a graphic diagram. Next, some examples of the use of the new package implemented in the Mathematica will be given. Okay, in this case, the binary relation and discrete sets A and B are integrated. The output being the binary relation by extension. In the second case, binary relation is entered both discrete sets and B. Also, diagram option is activated. The output for this case is the binary relationships by extension and its graphical diagram. Here are some examples of the use of the new package implemented in Mathematica. Previous studies reveal that the recognition of problem solving is a fundamental way to develop programming skills. Today, these skills are highly appreciated by the society. It is argued positively of the potential of computational applications in mathematics in basic and university education. It should not only be limited to software or program management, but also the acquisition of skills in the field of programming. Learning and programming language in students develops logical as well as creative thinking, strengthening structured and logical thinking for the design and understanding of program syntax, but is must be subject to feedback. The DiscreteSets.m package contains the command called binary relation, allows to enter the binary relation defined sets A and B. The output can be a list or a graph. Using a Raspberry Pi computer, for its low cost and the free version of Mathematica that runs on it makes the Mathematica package accessible to a greater number of users. Teachers will be able to use the discrete sets.m package to make their class highly interactive, while students can verify their results as well as acquire programming skills through the teacher's accompaniment. They could also parse the syntax of the binary relation command, like the sequential development of the necessary commands in configured procedures, the automation of the graphical representation, or the list of the elements of the binary relation for finite sets, including programming in the learning of mathematical constitutes taking advantage on the level of skill acquired, given the recurring demands of society. Finish.
Did you finish?
Yes, I finished.
Okay. Okay. Thank you. Thank you, Daniel. Are there any questions or comments? Okay. No question, no comments for you. See you. Thank you so much.
Thank you.
Bye, Daniel.
Bye-bye.
Bye. The last presentation, we can, okay, yes, using visual analytics to reduce churn. Who is going to present? Priscilla, Isabel, are you there? Maybe not. Nobody? No? Okay, let's go on. No? Okay. We can go on with the last presentation of this session, generating formal software architecture descriptions from semi-formal SysML-based models, a model-driven approach. Who is going to present?
I am Thais.
Thais?
I'm going.
Hello,
Yes. Thais. Yes, I will share my slides.
Okay, you can start. Thank you.
Okay. Hello to everyone. My name is Thais, and I will present our research entitled Generating Informal Software Architecture Description from Semi-Formal SysML-based Models, a model-driven approach, collaborating with Camila Araújo, Everton Cavalcante, and Flávio Oquendo. This work is in the area of software architecture. The software architecture definition is one of the main activities in a software development process. It allows anticipating important decisions about the system. This activity results in an architecture description that communicates the software architecture among stakeholders and supports its maintenance, evaluation, and evolution, in addition to providing support for automated formal architecture analysis. The formal architecture analysis aims to verify if design and architecture has essential properties such as correctness, consistent, and other properties. And an architecture description should be expressed by formal notation to support automated formal analysis. That is very important in the context of software architecture. However, software architects prefer to use semi-formal notations to describe the structure and behavior of software architecture, notations such as UML-based or SysML-based. This choice is mainly motivated by their lower learning curve, visuality, and general purpose scope. But this type of notation has no limitations regarding the support for automatically verifying architectural properties. Our work aims to present a model-driven approach to conciliate the rigor of formal architecture descriptions and the ease of use of SysML-based notations. The proposed approach intends to provide a formal semantic for Cjdl by transforming its model to Padl, that is a formal architectural language. Cjdl is a SysML-based architectural language for modeling software-intensive systems. It is in line with the international standard 42010 for architecture description, while Padl is a PyCalculus-based language for formally described software architecture. It allows the description of the structure and behavior of dynamic software architecture formally. Here we have a sample of the visual notation of Cjdl, where we represent the ideas of ports. The first part shows 2 composite ports. The second part shows 1 connector with its configuration. The third part shows 2 simple components, client and server components with the configuration. And the last part of the figure shows the architecture client-server arc and its composition configuration. This is the syntax, the visual notation of Cjdl that is based on SysML, with extensions to express abstractions that are typical from architecture, software architecture. Here we have a sample of the Padl notation. In the first part, we have 1 connection definition. Padl is essential textual language. The other part will show 2 components, client CP and server CP, and the architecture client-server arc and its composition behavior. Here it is illustrated the technical process that we defined to generate an architecture description in Padl from a Cjdl model. The transformation is supported by tools and artifacts complying with the framework Eclipse, Ecor, and Xtext. The Cjdl Studio and Padl guide the definition of syntactically correct model in Cjdl and Padl, respectively. This infrastructure allows verifying the architecture description in Cjdl and automatically generates a Padl description according to ATL transformation rules. We also have an architecture in Padl. It is possible to verify properties expressed in dynamic BLTL using the Plasma plugin for Padl. So this is the complete process for transforming and for verifying the formal specification. This is the flow chart that shows the initial algorithm to transform a Cjdl model into a Padl architecture description. The Cjdl architecture elements are stored on its respective sets, connectors, components, and architecture. Each Cjdl connector in the set is transformed into a Padl connector. Each Cjdl component stored is transformed into a Padl component. And finally, each Cjdl architecture in the collection is transformed in a Padl architecture. Of course, each of these steps is performed by other transformation rules and helpers methods. In industrial contexts, the adoption of formal verification approach has significant barriers, especially the scalability of the solutions, because of even more complex solutions with many components. Considering these, we evaluate in our proposal regarding scalability. The evaluation considers 6 descriptions of soft architecture in Cjdl, ranging from 10 to 85 elements. We separate the simple and composite elements because the rule complexity significantly increases when dealing with composite elements. We performed the ATL transformation 10 times for each test architecture and recorded the runtimes of our experiments. After confirming the sample normal distribution, we calculate the percent correlation coefficient to measure the degree of correlation between the amount of simple and composite structural elements and the execution of the ATL transformation from Cjdl to Pidl. The obtained values for simple and composite elements indicate a strong correlation between the number of elements and the execution time in both cases. The growth trend of the execution time is polynomial. When the architecture has thousands of elements, the execution time increases to around 10 hours, even considering an architecture with only simple elements, and 20 hours consider only composite elements. This is the concluding remarks. Our proposal presents the definition of formal semantics for Cjdl through a model transformation in Pidl, avoiding that the architectures have to deal with the complexities of formal semantics. The Cjdl specification transformed into Pidl are formally verified with Pidl formal analysis tools. The transformation from Cjdl to Pidl was implemented using ATL to validate the proposed approach, and an experiment was performed to analyze the transformation's performance and estimate its scalability. In terms of work in progress, we are extending the transformation from a behavior view. In fact, it is already done and it is under evaluation. We are integrating the Cjdl Studio tool and the Pidl toolset, and we are evaluating other aspects such as correctness of the transformation. Thank you so much. This is the end of the presentation.
Thank you so much, Thais. Are there any questions? No question for Thais. It's okay. Thank you so much.
Okay, thank you so much.
Bye.
Bye.
Bye. Meantime, is arrived somebody for present the first paper, a machine learning based framework for supporting malware detection and analysis. Nobody? Okay. And for the third, using a visual analytics to reduce churn. Nobody in? Okay. So this session is finished. Thank you everybody to participate, and see you in ICCSA. Bye. Bye.
Bye. See you.
Eccoci, siamo con questa. Allora,
streaming is on.
Hi, Miss Lee. If you want, you can try to share your screen. Hello, Miss Lee.
Hello.
Hi.
Hi.
You
I've
want?
tested it just now and it was okay. Thank you very much.
Okay. Okay.
Yeah.
So see you in 5 minutes.
Yes. Okay. All right.
Good morning, ladies and gentlemen. I ask you just some minutes because we have a problem with the camera. So I am sorry, but we need some minutes. Good morning, ladies and gentlemen. We don't solve the problem with the camera. We are very sorry, but we are late and so we have gone. I'm pleased to introduce this session. I remind you that you have 10 minutes for your presentation and 5 minutes for questions. I'm going to interrupt you if about a minute before the talk's finished, and I'm going to stop you once 10 minutes is up. Let's open immediately with the first paper, Lean Rehabilitative Predictive Recommender Games for Seniors with Mild Cognitive Impairment, a case study. The presenter is Chen-Xing. Chen, the floor is yours.
Okay, thank you very much, Dr. Francisca. I'm Chen-Xing, and I'm from Sangwin University in Malaysia. My student Wesley, he can't make it because he has some other commitments. This is actually his capstone project, and our title indicates exactly what it's about. It is on lean software engineering as well as trying to target at home-based rehabilitation and eventually to go into predictive recommender games. Okay, so without further ado, in terms of introduction, I think most of us know that in 2019, the World Health Organization has indicated that there are around 50 million dementia patients, and the cost of handling dementia globally has increased every year, estimated to be around $818 billion per year. So many research and also professional bodies have gone into research into how dementia can be possibly delayed, if not prevented. So what we are interested in is pretty small in terms of the big pictures. We are trying to do a recommender-based kind of mobile game for dementia patients, and because it is more on the computer science side, so we try to enable either manual adjustment or automatic adjustment of the difficulty to the player, because the seniors in Malaysia, some of them are not that tech savvy, so it would be better if the system itself adjusts accordingly. So how do we design? There are several prior works. One of them is based on the mini mental state examination test, and the other is on the Montreal cognitive assessment. both of them are indicated down there. So for the MMSE, the common assessment criteria are spatial orientation, object recognition or recall, attention and language. And for MOCA, there are similarities because after all, they are supposed to test progress or decline in dementia. So MOCA will look into the visual spatial as well, recall, attention and concentration with the addition of abstract reasoning, time, and also place. So to a certain extent, the foci are different. So since the MOCA is more sophisticated and it was just the first study on dementia seniors in Malaysia, so in my past studies with another collaborator, I actually did it with the Alzheimer's Disease Foundation of Malaysia, and we use the MMSE because there are only 4, whereas MOCA has more design considerations. So based on the MMSE constructs as well as discoveries and insights on the creative industries in terms of semiotics, since semiotics embody a lot of meaning and they may be more interesting with lesser cognitive load, then we try as much as possible to create lean, sustainable design, as well as 3 types of cognition, which are the embedded, embodied, and also distributed cognition, in order to help them to have more fun, as well as to be cognitively, affectively, and also emotionally stimulated. So in terms of prior work, we also have Big Gain Academy. So Big Brain Academy looks into several categories. So we can see over here that the first category is identify. Then we also have memorize. And then these two are similar to the MMSE and also the MOCA criteria. And then we also have this think category, analyze category, and also compute category. So to a certain extent, in terms of learning, these categories are similar to Bloom's taxonomy, but at the same time, they are also compliant with the standard dementia tests. Then there's also cognitive, and I've categorized them again into 3 categories. One will be the memory, concentration, and attention, because once we are able to address this to a certain extent, then we should be able to address the mental arithmetic, executive functions, and also reasoning. And finally, we should be able to use planning, mental agility, as well as coordination in order to handle the resource management as well as several other considerations. So this in a way is sequential, but in a way not so sequential, it's more cyclical. Then of course, for cognitive, there is the benefit of having very detailed statistics which track the user's progress as well as performance. And this will usually differ according to age and gender. And to make it even more stimulating, the performance is compared with the demographic peers. So they are more stimulated because they can see what their peers are able to do. And we hope that with this kind of motivation, they will be more motivated to continue by themselves and to even get to know more people. Right. And then there's the third one, which is MindMate. So MindMate is more on reminiscence therapy, because reminiscence is part of cognition and part of memory. So if anybody can remember, that it may actually be easier to do problem solving. So if that's the case, then yeah, the speed in terms of problem solving should also improve. And this MindMate study also finds that there is a diet, Mediterranean intervention for neurodegenerative delay diet, which is able to slow down dementia by 53%. So that's wonderful. The last one is WeFit. So WeFit also encourages elderly people to do yoga, strength training, aerobics, and also balance games. So we find that as much as possible, it's not just the cognitive aspect, but also the physical aspect, because we need to clear the blood vessels in order to get all the oxygen going to the brain. And therefore, any form of physical exercise will usually be much recommended. So other design considerations other than these 4 will be to elicit from the literature review very specific values for these variables. So with regards to suitable duration, with regards to how short and simple the instruction should be, and also with regards to how much time there should be, and also the error rate. So all these factors are derived from literature which is reviewed, which Wesley did. Okay, then in terms of the methodology, we followed the waterfall methodology, and because we have to get the consent from the Alzheimer's Disease Foundation of Malaysia, therefore we drafted the survey to ask the seniors and also their caregivers what they think about the proposed design. And after they have consented and we have analyzed, then we went into the development aspect using Godot. Okay, and then after that, of course, we did the beta testing using Google Survey and also the caregivers. Okay, so my region's design, my region is the name which is coined by Wesley, is based on three, the assessment, rehabilitation, and also prediction, because we need to assess based on the MOCA and also MMSE to a certain extent in order to rehabilitate, and based on their prior gameplay, we should be able to predict whether they have certain problems in certain aspects based again on the MMSE and also the MOCA measurements. So there are two mini games. One is the matching game, which aims to address the attention and memory. The other one is a fishing game, which aims to address the attention and motor skills. So again, we see that the motor skills comes into picture because they need to exercise as much as possible in order to get the blood running, okay, and the oxygen to go up to the brain. So here we have a rehabilitation and also calibration, and calibration is where the recommendation comes in. So this is where the seniors gameplay is tracked to a certain extent, and based on this, then it is adjusted, and then the gameplay is also used to predict the seniors' eventual ability. These are some of the designs. You can also read these from the published paper, and therefore you see that the first thing that the senior can do or the caregiver can do is to click on play, then choose to play which game, and then after that, the person can either choose to adjust manually or to allow the system to calibrate after 2 calibrations. So these are the 2 calibrations. The first calibration is a matching card game, and then it will indicate, which level the person should go for.
1 minute, please.
Yes. Okay, then this is the circles clicking game. And the rest, I think you can look at it. So the most important part is this one. This is the cumulative score for each question, and this is the average. So we can see that in terms of ease of use is the highest, followed by usefulness, and then followed by stimulation, and also the intention to use in the future. The other slides are all about each factor against the other factor, because I was trying to establish the Pearson correlation to know which factor will be able to match best with each factor, simulating association rule to a certain extent. Okay, so in terms of the findings, they are very positive, but because the sample size is pretty small, the findings are not generalizable. And we just want to say that it is possible even now during the pandemic to play these games with the seniors at home, because they say that it's pretty stimulating, and in the future maybe the data can be captured and shared with the doctors so that the doctors can do telemedicine kind of advising, and of course with the family consent, maybe further interventions can be designed. So thank you very much to all these people who have helped us in our study. Thank you.
Thank you, Shansing. Are there any questions? No questions. Very interesting to work for a big problem. Thank you, Shansing.
Thank you, Dr. Francesca.
Okay.
I would have a question.
Okay. Sorry.
So my name is Angela. I am not at all in this field, but I found it very interesting. My question would be, what is your and very well and clearly presented also. So my question would be, what is your direction of future research? You probably have some plans to continue this.
I am not so sure yet because it all depends on funding. So the future research, which I mentioned in the paper, was that if we have consent from the seniors as well as their caregivers to track their data, then we can do further analysis and design further.
Yeah. Thank you so much.
Thank you very much for your question. Thank you.
Any more questions? No? Angela, you are the second presenter for the presentation for the work early fault detection with the multi-target neural networks. The floor is yours.
Thank you so much. I try and share my screen. Let me. I guess you can't see it yet, can you?
No.
No. Then I propose someone like the next speaker goes next, and I try and can I send you my presentation by email because I'm not sure. I think there's an issue here with the sharing.
Okay, I'll leave you my address in the chat. Okay.
That would be perfect, and then I could, if it doesn't work out, I could go in the end. That's fine with you.
Okay, I will share it for you. That's okay.
Thank you.
Okay. So the next one.
The next time. Challenges regarding the compliance with the General Data Protection Law by Brazilian organization, a survey.
It's me. Can you hear me?
Yes.
Okay, I'll share my screen.
It's Ana Paula.
Ana Paula?
Yes, it's me.
Okay.
Can you see my screen?
Yes. You can go on.
Okay. Hello, everyone. This is a project about the challenges regarding the compliance with general data protection law by Brazilian organizations, a survey. I just want to thank very quickly our sponsors, the Research Support Foundation of Goiás and the University of Brasilia Laboratory of Decision-Making Technologies. This is my agenda for today. I'll talk about an introduction, the need of laws to protect personal data, movements of Brazilian companies to adapt to the Brazilian law, which I will call LGPD from now on, a background, a little bit about the law, definitions, the law scope and purpose, our study settings, how we conducted an investigation about the aspects that the organizations had to address in order to implement LGPD, results and conclusions. As systems became very geographically distant, we saw the need of making an overview of LGPD implementation process by public and private organizations in Brazil and how compliant they are with the legislation nowadays. So as systems became very distant from each other, and many laws about data protection were emerging in Europe and other countries such as Australia and US, Brazil had to adapt to this law. So LGPD came into force in September 2020. And a very large number of Brazilian organizations controls data considered sensitive by LGPD. So there is this law number and it's a law that regulates activity involving the processing of personal data, including digital media, with the purpose of protecting the fundamental rights of the citizens to freedom and privacy. Although these fundamental rights were already protected by the Federal Constitution of Brazil, it was only after the enactment of LGPD that the privacy of personal data acquired some relevance. So basically, the Article 3 of the law established that the law applies to any processing operation carried out by legal or natural personnel under publicly or private matter, and has the object of provisioning of goods and services, or if this data has been collected to Brazil. These are the scenarios where the law applies. The Article 4 deals with the cases to which the laws does not apply, which includes journalistic and artistic purposes, academic or public security and national defense, state security matters. So the Article 5 of the law establishes definitions for terms used there, such as personal data, what is sensitive personal data, what is how to deal with shared use of data, and Article 6 defines the principles to be observed in data processing process as the purpose for this, such as adequacy, data quality, transparency, how organizations have to tell their customer they're using their data, accountability, who is responsible for the data inside an organization. And one aspect that LGPD and GDPR are very similar is the requirement to hire a data protection officer, which is a DPO. This professional should serve as a communication channel between the controllers of the data, the information holders, and the National Data Inspection Body, which in Brazil is called ANPD, and it is responsible for inspecting and imposing sanctions to organizations that do not adhere to LGPD. To comply with LGPD, Brazilian companies must take, among other measures, such as analyze and verify which data falls with the scope of LGPD, correct incomplete or inaccurate, outdated data, and obtain information about public and private entities with which the data controller shared the data before, and obtain information about the possibility of the information holder, the person to which the data belongs, to deny consent and the consequences of such denial. In addition, the law requires companies to collect the minimum possible amount of data they can and process it only on legal grounds. So our study settings developed 40 questions, 38 which are closed and 2 are open, using mainly the Likert scale. The survey was designed along 3 axes, which was about democratic issues, general issues unrelated to LGPD, and questions about principles and compliance with LGPD. We made the survey available through Google Forms, which the link is available on our research. And the response time of the participants was approximately 10 minutes. The survey was available for 30 days. And in total, 61 practitioners responded to the survey. Now I'll present some results. The distribution of the organizations that the survey participants worked showed that 57% work in private organizations and 42% in public and governmental organizations. With this number, we can see that there is a good balance in the nature of companies that participants work with, helping to measure the adequacy of Brazilian companies in general very well. So with these results, we also have the amount of experience that the participants had. We can conclude that most participants have extensive experience in the area of information communication technology. So the questions showed that question 8 asked about if the organization had a DPO, and 46% showed that the companies have 46% of the companies have. And this finding is worrying because less than 50% of organizations have a DPO, and it is one of the obligations that determined by the law. Also, 33% of organizations use a specific methodology or technique to elicit privacy requirements. This is question 9. This is also a number far below what is expected, as a data privacy policy needs to be defined so that organizations can comply with LGPD. Question 22 showed that 80% of organizations allow access to personal data only by authorized people, which allow us to infer that the organizations participating in the survey are in compliance with the principles of LGPD. And question 23 showed that only 25% of organizations treat personal data of children and adolescents. And only 22 of them carry out different treatments of personal data and children and adolescents data, which is question 24. According to these results, we can conclude that more than 70% of organizations participating in the survey do not deal with data from children and teenagers. And the last one, 46% of organizations use encryption techniques to anonymize controlled data, which is question 38, and only 33 of organizations anonymize all user data, which is question 39. So this result is quite worrying, since that one of the principles of the LGPD is that data anonymization is data anonymization, and few organizations carry out this type of activity. So 96% of the professionals who participated in the survey reported that their organizations have already suffered some sanction from the National Data Protection Agency, and it made us conclude that Brazilian organizations are not yet in compliance with LGPD, since the number of sections of the body responsible for controlling the implementation is very, very high. So this is it. We conduct a survey to investigate how companies are adapting to LGPD principles and whether they are in compliance with them. Most practitioners had 16 years of experience in ICT. The results revealed that practitioners know the principles of LGPD and that organizations they work with are adapting to what is required by the legislation. Most organizations doesn't have a GPO, but they train their employees in relation to LGPD. And also, according to our findings, we can conclude that Brazilian organizations are adopting sensitive data control mechanisms and are committed to achieving compliance to the LGPD. Okay, so that was it. Thank you so much.
Okay, thank you, Ana Paula. Are there any questions for Ana Paula? No question? No comments? So we can listen now Angela Meyer with the paper Early Fault Detection with Multitask Learning for Data-Driven Condition-Based Maintenance.
Thank you so much, Sarah, also for inviting me. So my name is Angela Meyer. I am a professor at the Bern University of Applied Sciences in Switzerland. And my presentation has a long title, so let me explain the field which I'm working in. It is data-driven condition-based maintenance. So we're focusing on industrial systems, like you can see in this picture, for instance, renewable energy installations. And our goal is to provide an improved maintenance by more informed maintenance by 24/7 condition monitoring, and then basically throwing statistical and machine learning models on the data that we get on the health information from these systems, from the wind turbines and other industrial systems, in order to provide cheaper monitoring and more informed maintenance possibilities to the operators. Next, can you go to the next slide, please? So this is just showing you that this topic is actually quite important in industry today, because we have installed capacity of renewable energy, and in this case, wind energy is growing very strongly. We're at around 600 gigawatts nowadays, and it's growing fast, and it's going to the future source of energy. Next slide. This shows you the situation in the US, where we expect a doubling of the installed wind infrastructure, wind power generation infrastructure over the next 10 years. So that's pretty impressive numbers. Next one. And as you can imagine, the larger basically we're completely tearing down the existing power generation infrastructure and building up a new one. So this is a huge infrastructure program, and this also means that we want to run and monitor the new infrastructure as cheaply and efficiently as possible. So the need for maintenance and cost-efficient maintenance becomes larger as the fleet is growing. Here you can see the expected operational expenses in green for North America. So this is growing over time. Next one. So how do we do this? I've given you the motivation, basically. Well, what we need to provide automated condition monitoring and make operators aware of developing faults and issues and underperformance in their machines, what we need for this is, of course, real-time information about the actual health state of the machine. So you can see here on the right-hand side a wind turbine. This is the example that the wind farm is an example that we have worked with in the study. And wind turbines are marvelous machines in several regards. And one of them is that for a machine learning person like myself, you get a lot of interesting data about the health state of different components that are built in this wind turbines. For instance, you can see here you have different temperature readings from bearings in the drivetrain. You have vibration monitoring measurements in the gearbox. You have you measure the oil properties, for instance, of the gearbox oil, and there's many other things. You have hundreds of sensors that you get data from in real time, which is really nice. Next one. So how do we approach this? Wind is a very variable, non-constant quantity, and also the power that is produced by these engines is not at all constant. So how do we learn or automatically detect when there's an issue in a component of the turbine? So what we do typically for this is, well, as a machine learning person, you would first of all maybe think of a supervised approach. So you would think, well, we can just look for what faults look like in the data. So what does the data look like before we have a fault? And then we just train a model for this. That's a good idea. Problem is that we don't have enough data that is, for faults. And so we take another approach here. That's typically taken in the industry. That is, we take an unsupervised approach. So we learn what the normal behavior of all of these sensors looks like, depending on the environmental conditions. So this is on the left-hand side, you see a model, a very simple model that predicts the power that is generated by a turbine as a function of two variables. That's the wind speed on the one hand and the wind direction on the other hand, because they are the most important explanatory factors. Next one, next slide. So, and this is actually done in industrial companies. So they have remote monitoring centers, and they fit these kind of models for the different all of the assets they have, and then they let these models run, and they will be alerted in case there is some unusual behavior going on. So the next thing that is typically done is, okay, I have a model for the power now, well, but I have so many other variables that I want to monitor. So let's build another model. Well, you set up another model for the rotor speed, for instance, and so on. So you end up with lots of models, a large number of models. But in reality, we're actually in a multi-dimensional space. You can see this on the right-hand side in this figure. We're actually basically on the black line, this subspace made up of power and wind speed and rotor speed. But building all of these single models is the same as means you're just projecting on all of these subspaces. You have lots of separate models. Next slide. This is what you can see here. You will end up with hundreds, if not thousands, of models per turbine for every single turbine. And you have, of course, many of these turbines in your portfolio if you're a big utility company. Next one. And that is basically like you end up with a zoo of models, which is in practical operation, a problem, because can become a problem because all of these models, they also need maintenance at some point. Sometimes the parts in turbines are exchanged, and you will need to update your model. You cannot just train it once and it sits there and forever. But these models need to be looked after. So there is a practical problem here. Next. So I'm presenting a study. So the point of my presentation today is to show you that, first of all, we can come up with a new approach here that has not been taken so far in the field of renewable energy, and especially in wind turbine condition monitoring. And that is the approach of predicting or monitoring multiple target variables at the same time. So instead of having a single model, one for power, like I showed you, or one for rotor speed, we have a model that outputs and predicts multiple variables at the same time. And this approach we've investigated this. You can see this here in this publication, Applied Energy. And in short, it has several major advantages. One advantage is that it turns out that this multitask learning approach is actually enables more accurate predictions, because the multitask models, when they are trained, they can basically make use of covariance of the target variables. So and we show an example in this paper where we get actually more accurate description of the normal behavior, which is nice because it enables you to detect developing faults earlier. And if you become aware of a developing issue in one of the components, for instance, in the gearbox of your turbine, if you become aware of it earlier, that gives you more time to respond, and that also prevents basically larger damage to happen. So this is a nice thing. As a third result is that, well, also practically, multi-target models may be beneficial, as I mentioned already, because you don't end up with a zoo of hundreds of models, but you have just a smaller number of models, basically, that you need to look after. And what you can see on this slide is basically the overview or the introduction to this paper, where we show an example of the input and output variables that we have taken for this multi-target approach. So there's the wind speed and wind direction in this upper left panel, and then there's the power as an output variable, and on the right-hand side, the rotor speed, generator speed, and current also as output variables. They are very variable, as you can see, and that is
1 minute, Angela.
everything.
Sorry.
1 minute?
1 minute more. Yeah.
That's perfect. No, that's fine. Let's just jump to the last slide, if you can go there, unless it takes a long time, because I basically gave you all the results, and you can, if you're interested, look at the two papers that I'm presenting. So to summarize, we have shown in these two studies that multitask learning, so multi-output models, are very useful for monitoring wind turbines and for early detection of faults in commercial wind turbines. The current state today is that operators are using, and also in research, everyone is only so far using single target models, and there's hundreds of them. And that in practice, this is becoming an issue, because it leads to a piling up of independent models that don't use covariances and that are just impractical to deal with. So yeah, thank you so much, and I'm happy to take questions if there are any questions.
Thank you, Angela. Are there any questions? No questions? No? Okay, we can go on with the last presentation. It's about a novel approach to end-to-end facial recognition framework with virtual search engine Elasticsearch. Who is going to present this paper?
It's me. Hi.
Hi.
So I would like to share my presentation. Can you see the slide?
We can see your slide, your first slide, yes.
Okay. So I would like to begin my presentation. Hi everyone. It's an honor to be able to participate in ICCSA 2021 and to present our paper today. We would like to introduce a novel approach to end-to-end facial recognition framework with virtual search engine Elasticsearch. In this paper, we propose a full pipeline for an effective face recognition system based on a vector-to-string token conversion algorithm and the Elasticsearch engine. It requires only a small dataset and CPU instead of GPU for training. And in comparison with other state-of-the-art algorithms, our proposed pipeline not only achieves higher accuracy, but also deliver faster inference, which is essential to real-time applications. Facial recognition has been one of the most appealing research topics of the last few years. Companies and government all over the world are giving great attention and investment to this technology because of its great potential for application. For example, it can be used on security, law enforcement, banking, etc. Facial recognition is the process of identifying or verifying the identity.
Sorry.
Sorry?
We can see just your first slide.
Oh, okay.
Okay.
Can you see the next slide?
The introduction. Okay.
Okay. So okay. So I would like to continue the presentation. As you may know, facial recognition is the process of identifying or verifying the identity of the person using their face. It usually involves 4 following steps. First is face detection, face alignment, face capture, and finally face matching. Each of the 4 steps above can be performed efficiently by many advanced algorithms. However, when it comes to the full pipeline, we don't find many research on the topic. Also, the use of deep learning models results in higher accuracy, but those models need to be trained on an extremely large data set of millions of images. As a result, it leads to rising requirement and demand for expensive GPU servers, or otherwise we just have to accept a slow system. Another challenge is called the online learning problem. The fact that in reality, a facial database can be updated with new face on a regular basis. So in order to maintain the accuracy of the system, the training has to be performed over and over periodically. Motivated by the challenge above, we were able to propose a new approach to solving the problem. We were able to deliver a complete pipeline for an end-to-end facial recognition system consisting of all the phases from development, deployment, and model version management. Compared with other well-known methods, our pipeline not only provides higher accuracy, but also takes less time for inference, and therefore responds faster. It's noteworthy that our proposed pipeline was trained on a very small and challenging dataset, not a massive dataset. By applying a vector-to-string token algorithm in the extraction step, we were able to use a CPU instead of GPU server for training, development, and deployment. And finally, by making use of the elastic search engine for the matching step, we don't need to retrain the model every time new faces are added to the database. Next, I would like to introduce a little bit about the dataset we use for experiments. It is called the VN Celeb dataset. That is a collection of Vietnamese celebrities' image taken from Google Image. There are 24,000 images classified into 1,020 classes. So it is the average of 23 photos for each celebrity. This is a very minimal number comparing to other datasets like FaceNet or DeepFace with more than millions of images. Let's take a look at the distribution of image for each class, and you can say that this data set is heavily imbalanced. There are 7 classes which have only 2 images, and the class with the most image has up to 105. Other problem affecting recognition is that the photos are in poor lighting condition, have many different poses, and showing bad picture quality. In the next section, I would like to demonstrate our proposed method. Please take a look at the graph. Here you can see our proposed pipeline for face recognition system. Because of the time limit, I will introduce very briefly our common face. We start with an input image, which is the green one at the head of the graph. The first step is face detection. Since we were face detection, for this we can use one of the two methods, MTCNN or MobileNet SSD, to find the location of the face in the image. Next is a data preprocessing phase. Since we were dealing with a challenging data set, to improve the system accuracy, we decided to generate more data for the 7 class that have the least image. After that, the data set is passed through the next step, which is face representation. The phase from the previous step is fed to a deep neural network in order to create an embedding vector. Based on our experiments, we concluded that VGG phase works best for our framework in terms of both accuracy and performance. The output representation vector is supposed to be used for identification. Since the default output dimension of VGG phase is 2048, this is a very time-consuming process which required very high computational power. Therefore, we need to reduce the vector's dimension, and we applied PCA to compress the representation vector from 2048 to 512 dimension. Next, I would like to talk about the core part of our paper, which is the encoding algorithm, which is to convert the face embedding vector to a collection of string tokens. And after that, the string tokens can be used on Elasticsearch engine. The encoding algorithm is inspired by the idea of subvector-wise clustering. Let's say we have a numeric face vector of d dimension, for example, 512. We can divide it into m subvector, let's say 16. Then we will have a 16 small vector with a length of 32. Next, we will apply k-means algorithm to assign each subvector into one of the k clusters. We can take the figure in the slideshow as an example. We will have the first subvector belongs to cluster number 4, and the second subvector is assigned to cluster number 3, and so on. Then each subvector is encoded into a string token by combining its position and the cluster it belongs to. So as a result, we will have m string tokens produced. So from the figure in the slideshow, we will have the following array of string tokens, which the first element is position 1, cluster 4, the second is position 2, cluster 3, and so on. Now that we have all the face vector converted to string token, we want to store them for further inference. For our pipeline, we use the search engine called Elasticsearch in order to achieve an optimal string matching mechanism. To index data into Elasticsearch for each data item in the dataset, we will construct a JSON format containing all the necessary information. Then we can use available Elasticsearch API to index data into Elasticsearch server. And with any query image, we apply the same step as above to attain a string token, and then use it for searching with Elasticsearch API. The API will return the top 5 results. All we have to do is take the embedding numeric vector of the 5 chosen one and compare to the query one by cosine similarity, and choose the one with the highest score, but still greater than the threshold. The next slide is an example for the JSON query constructed for inference, which you can find more detail in our paper. At this point, we have several models from the previous step, like face detection, face embedding, and the encoding model. So with the two first deep model, we convert them to TensorFlow PB format, and using TensorFlow serving API to serve and manage in a separate server. Regarding the last one, the encoding model, we use data version control. And in order to make our application available to the community. Our application was developed and deployed on the Django framework. In order to prove the validity of our proposed pipeline, we compare our pipeline to OpenFace, another well-known framework. So here we have these three tables, which demonstrate the result, including accuracy, recall, and inference time. The two more.
1 minute.
Okay. And in terms of, you can see in terms of accuracy, our proposed model outperforms OpenFace in all the experiments. And when it comes to recall and inference time, OpenFace get higher score, more than half the time, but our results are also comparable for higher number of positions. Here is the bar chart. On the right side, we visualize the evaluation metric between OpenFace and our model. And you can see that our system bring about many benefits to face recognition application. Finally, in conclusion, our paper have proposed a new approach for an end-to-end facial recognition application with full pipeline, and it have to solve many all the challenge mentioned above, like the lacking of facial data, the requirement for expensive GPU server. It delivers better inference, better accuracy, and comparable reference time when compared to OpenFace. And since Elasticsearch is leveraged for storing, creation, and retrieval of face identification, we can solve the online learning problem, so that we don't have to retrain our model every time the face, a new face was added. That's all for our presentation, and thank you for listening.
Thank you. Thank you, Hong Kong. Are there any questions for her? No questions? Okay. That's all for this morning. Thank you, everybody, presenters for their presentation, and the attendees. Let's see in ICSA. Bye.
Bye.
Bye.